So the pressurized atmosphere is kept there by gravity, as I said multiple times. So
hi, I'm Emerald Robinson, and in this What Is video, we're going to investigate the state of matter called a gas. Gases are materials that have no definite volume and no specific shape.
Your whole idea of, Mark has no answer. I do have an answer. Sphere is kept there by gravity.
Third, gases can flow from one area to another, although the direction of flow is not directly affected by gravity.
Sphere is kept there by gravity.
Although the direction of flow is not directly affected by gravity. Although the direction of flow is not directly affected by gravity.
So if the Earth had a container, as you claimed, you made a claim there that the Earth has a container over it, what ought to happen, according to the second laws of thermodynamics, is that the air should equalize to become the same pressure, like in an aeroplane or like in any other container.
Molecules in a gas collide with one another and move more quickly or more slowly based on factors like temperature and pressure.
It would not have a pressure gradient going up from high pressure at the bottom to low pressure at the top.
Good times for all. There's actually Zabala here if you prefer. What we have is a bucket of ice water. Okay? So, and that hose is coming out right here and it runs up to this pressure reading gauge right here, which, as you can see, is right at about 3. And this one is right at about, it's under 2.5, almost to 2. What I've done is I've taken this heating gun up to 800 degrees, and then we have the bucket of ice water at the bottom, and I'm changing the temperature, hopefully, at both ends.
And this is where you have absolutely proven yourself wrong, because if there was a physical container there, the air would equalize and all become the same pressure. But we know that going up a mountain, the air becomes thinner.
Everybody knows that it's colder up in the mountains than it is down below, and the difference can be quite substantial. Now, to understand why this change in temperature happens, we need to understand a little bit about gases.
In order to study the relationship between pressure and temperature, we will heat up a gas which is enclosed in a tight container. While we are heating the gas in the container using a burner, we can see that with the increase in temperature, the pressure of the gas also increases. And when we cool the enclosed gas, we can observe an obvious decrease in its pressure.
Now, when gases are compressed, they heat up. And when gases expand, they cool down. When the gas is compressed, it's going into high pressure and getting hot. And when it's being expanded, it's going into low pressure and getting cold. So the gas starts out at a certain temperature, and as it goes up to low pressure, it's being expanded and getting colder.
It becomes less pressurized. People have to take oxygen up Everest.
It's 2 cylinders. It contains all the regulators, the delivery mechanism, and the face mask.
You are absolutely wrong. And you've just shown that by claiming that there is a container around the Earth.
Let's just take a gas in some volume, V, and over here is going to be vacuum of equal volume, and we're going to remove the barrier. You know what's going to happen spontaneously, right? The gas is going to fill the available volume once it becomes available, right? You know what's going to happen spontaneously, right? The gas is going to fill the available volume once it becomes available. And we're going to remove the barrier. The gas is going to fill the available volume. Take a gas, and over here is going to be vacuum, and we're going to remove the barrier. You know what's going to happen spontaneously, right? The gas is going to fill the available volume.
Because if that was there, all of the air would equalize. Excuse me, would equalize. Now, this is the same thing you're claiming, where the air should go out to space. It should equalize, yes, but gravity is holding it down.
Although the direction of flow is not directly affected by gravity.
One of these bulbs, some bromine, and in the other, I have a vacuum. And if I open the tap between these two, you will see spontaneously the bromine rush from one to the other. Now that is the simplest change we can have, perhaps, because all that happens is a change in entropy. In this case, the expansion into a vacuum, nothing else is involved. There's no energy change, there's no temperature change, there's no change except entropy.